Hello students, I am Dr. Sanjeev Punia. In last lecture of computer architecture, we were discussing about DMA, that is direct memory access, and we saw that how a CPU works when we are not using DMA in our computer system, or how the performance of system is going to degrade when a DMA is not used inside the computer. So we saw that what happens when DMA is not present inside a computer, and we left in the last lecture that we will discuss that how the things are going to perform when we implement DMA. So there are lot of operations in which there is no need to interact CPU directly. In that case, there is some other hardware that can manipulate or that can work based on that information or that process. A feature of computer system that allow certain hardware or subsystem to access main memory independent of the central processing unit is the feature where the main memory access, that is RAM, random access memory, can be accessed directly without the interruption of the CPU. So without DMA, we discussed that as the speed of many devices is very low compared to central processing unit, as generally the input and output devices are serially used, whereas the speed of drive is also very less. So without DMA, when the CPU is using performed input-output operation, it is typically fully occupied for the entire duration of the read or write operation, and is thus unavailable to perform other work. So CPU control wait continuously for an input information till when all the information has to be received, and it cannot perform any other work, and especially dedicated for the input information. So this can be complete using DMA, or this problem can be overcome with the use of DMA. So with DMA, the CPU first initiate the transfer, then it does other operations while the transfer is in process, and it finally receives an interrupt from the DMA controller when the operation is done, or the when operation is complete. So this feature is useful when the CPU need to perform useful work while waiting for a relatively slow input-output data transfer. What happens that in system, lot of processes are performed parallelly. If there was only and only a single process, then there was no problem at all. CPU can wait for the input information, but lot of operations are going to be performed parallelly. So after initialization that I want some information, it keep control, it sends signal to DMA, and after that it switch over to other operations. And when the full of full information is get to received by the DMA, in that case it interrupts the CPU. It informs the CPU that I have done my work complete, now you can take the information. This is a diagram without DMA. In this, we are not using the DMA. You can see from here that this drive speed is very slow, very slow, and CPU has to be wait to take the information from here. So then the controller throws an interrupt so that operating system can read the block from the controller buffer and read the data byte by byte. After reading each and every single part of the block to the controller device register, the operating system will store them into the main memory. This is the process that happens without DMA. Now, when we are using a DMA, in that case, this DMA controller is used between CPU and this memory so that this DMA can interact with the memory, that is with the drive, to receive the information. So we will see now step by step that what is going to happen. So when the CPU wants some data from the drive or from the input output device, in that case CPU generate a request. CPU generate a request and send to DMA. That is, first CPU programs the DMA controller by setting its register so it knows what to transfer where. It also issues a command to this controller telling it to read data from the RISC into its internal buffer and verify the checksum. When valid data are in the disk controller buffer, DMA can begin. In it, CPU put the request to the DMA controller that it wants some data, and side by side with the request, it put the address that from this address the information or data has to be picked up. So this is the first step where CPU performs an request for the information to DMA controller. In second, DMA controller send a request to transfer the data from drive to main memory, that I want to receive some data from this address. Address is also sent at the time when DMA request to disk controller about for the information. So the DMA controller initiate the transfer by issuing a read request over the bus to the disk controller. This read request look like any other request, and this controller does not know or care whether it comes from the CPU or from the DMA. So this controller have to perform its work only. It does not take care that from where the read of the request of received data has to come from CPU or from DMA. In third step 3, DMA sends the data to the main memory. DMA sends the data to the main memory, and the work of the DMA has been completed over here. The main purpose of disk controller is to control the disk and read and write data into the disk. So when DMA request for some data transfer, then it took the data from the drive and sent that data to the main memory. So typically the memory address to write to is on bus address line. So when the disk controller fetches the next word from its internal buffer, it knows where to write it. In step 3, the write informations has to be sent to main memory, but after sending the data to the main memory, the CPU also have to be acknowledged that now data is in the main memory and you can take the data from the memory. So this work is done by the disk controller. Now disk controller sends a acknowledge to the DMA controller that my work has been performed, or I send the data to the main memory. Now you can do whatever is your requirement or whatever you want to do with the data. When the write is complete, as I told you, when the write is complete, the disk controller sends an acknowledgement signal to the DMA controller. The DMA controller then increments the memory address to use and decrement the byte count. If the byte count is still greater than 0, then step 2 to step 4 are repeated until it reaches to 0. Means again and again it will going to check that I have to perform any other work or not. This is going to perform, or this is going to control by the counter. So this was the thing that has to be performed, and in the last, DMA sends a signal, sends a interrupt signal to CPU that now the information that you want has been completed. Means whatever the information you asked for, that is in the main memory and you can use that information. Then after getting the acknowledgement or after getting the interrupt from the DMA, CPU reads the information from the main memory. So this is the reason that till when or between the process, the data is going to transfer from the main memory to CPU. Only during this the CPU is has to busy and 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 it has to be interrupt for the other word whatever the word CPU is doing. Means after getting the interrupt from the DMA, CPU leave the operation and put that in some buffer so that when it will return back, then it will resume or it can resume that process, that operation from there. So after receiving the interrupt from the DMA, it going to access the data through the bus in the main memory. And when it receives the information data from the main memory, CPU can perform as it was processing or it was doing its process earlier. So this is the way in which the speed of the CPU can be enhanced or it is not bothered at how the data is going to proceed when it wants some information from the input output or from the drive. So at that time, DMA controller input interrupts the CPU to let it know that the transfer is now complete. And OS starts up, it does not have to copy the disk load to the memory as it is already there that is transferred by the DMA controller. So this was the basic concept when we are using DMA between CPU and main memory or input output device. So this work can be done in two ways. So bus can be operated either through the word at a time means word by word or the block at a time means the data is going to store in the buffer and when the buffer is complete means when all the informations is going to store in the buffer that at that time complete information is to be read from the buffer. So you can see over here that this operation can be done byte by byte or by plot mode. So here the DMA request for the transfer of one words. Transfer of one word. If CPU want the bus at same time, then it has to wait continuously for a long time. This mechanism is known as cycle. But when the data has to be read in block mode, through block mode, the DMA controller tells the device to acquire the bus and issue a series of transfer and release the bus when it is not using. This form of operation is called burst mode because the operations are going to perform in the chunk and whatever the CPU is performing then CPU takes some time or steal some time from that operation that is not dedicated permanently for that operations. It is more efficient than cycle stealing. So we discuss over here that how the DMA works when the when we are not using the DMA, then how the speed of an computer is going to be decreased, and after implementing the DMA operation, how the speed of a system has to be multiplying many times or increasing exponentially. So this was the basic concept, and DMA is also a good technique by which the throughput and efficiency of the system is going to be enhanced. So this was about the DMA. Now the third